I welcome all of you to the class. As far as the today's class is concerned, in today's class we'll be talking about the concept of curve fitting. So today's lecture is, I guess, lecture 15, and we'll be talking about the concept of curve fitting. As far as the concept of curve fitting is concerned, for example, we are given some values of x, like we are given x is equal 0.1, or we are given x is equal, say for example, 0.1, 0.2, 0.3, 0.4, 0.5, and 0.6 or 0.7, so on. And corresponding values of y are like at x is equal to 0.1, y is 1 or 1.2. At x is equal to 0.2, y is 1.6. 0.3, y is equal to 2.2. 0.4, it is 2.8. Here 0.5, it is 3.0, and this is 3.6, say for example. Now we are given some values of x and some values of y. So if we call this as our x-axis and this as our y-axis, okay, though, so at x is equal to 0.1, the value of y is 1.2. It is here. For example, at x is equal to 0.2, the value of y is equal to 1.6. It's somewhere here. So as we plot all these data, as we get all these data, so they will be in the form of a, they will be scattered. Okay, these points will be scattered points. The, the values of y corresponding to the values of x, okay, will be scattered on an xy plot. So what we want that all these points should be represented on a straight line. Say for example, we want the one point we are having here, another point we are here, another point here. So we are having the points, the x and y data that we are obtaining, that is given to us. It's in the form of a scatter diagram. Okay, there's a scatter. We want that these points should be represented in the form of a straight line. That is, we want this point to be here, we want this point to be here, this point to be here, this point to be here, so on. We continue, and we want to represent all these points which are actually scattered. We want that they should be represented in the form of a straight line. Okay, but while we are doing it, we should be careful that the information of the data should not change. The information of the data should not change. Information of data should not change or should not vary. Okay, what does that mean? It means, say for example, at x is equal 0.1, the value of y is 1.2. So x is equal to 0.1, the value of y is 1.2. It is somewhere here, but we want to represent all these points on a straight line. So we are actually saying that this point is not lying here, it's lying somewhere here. Okay, so it means as we represent this data in the form of a straight line, okay, that straight line will have some equation, and we know the equation of straight line is y is equal a2x plus a1. This is the equation of a straight line, or what we have been saying as y is equal to mx plus c. Okay, so the data that is scattered, that is this data, okay, corresponding to some values of x, it's scattered data, but we want that this data should be represented in the form of a straight line having this equation. This equation is to be selected in such a way that as you give the value of x1, as you give the value of x is equal to 0.1, the value of y should be equal to 1.2. As we give the value of x is equal to 0.2, the value of y should be, the value of y should exactly be equal to 1.6. As we give the value of x equal, say for example 0.5, the value of y should be equal to 3. That is, the value of y corresponding to the values of x should be same as the values of y given in the table, corresponding to the same values of x as given in the table. Okay, This is fitting a straight line. The data that is given to us is to be fitted on a straight line. That's one thing. Number two is sometimes we are asked that the data is not to be fitted on a straight line, but it's to be fitted on a nonlinear function. Okay, it is to be fitted on a nonlinear function. Nonlinear function may be an exponential function. Okay, it may be an exponential function. The concept is same. That is, the data that is given to us now needs to be represented in the form of an exponential curve. Y is equal to a e raised power x. Okay, so a is some constant. Fine. The data that is scattered needs to be represented in the form of an exponential graph like this, whose equation is y is equal to a e raised power x. In part one, we'll be understanding how we can represent the data in the form of a straight line. Then in part two, we'll represent the data in the form of a nonlinear function. Let's talk about the straight line fitting. So let me say, this also called the regression line. Um let's suppose we are given some data. The value of the data is, we are given the value of x, and corresponding values of y are also given to us. Okay, so the value of x is, let me suppose 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5, and 0 0.6. The corresponding values of y are 5.1, 5.3, 5.6, 5.7, 5.9, and 6.1. Okay, so this is the value of x, and this is the corresponding value of y. So we are given the values of x and y. Okay, so now what we'll be doing, we have to represent this data on a straight line, okay, such that the equation of the straight line is y is equal a2x plus a1. Okay, where a1 and a2 are constants. They are the constants. So how we represent them? So first of all, what we do, we will find xi square. Then we have to find the yi square. Then we have to find the product, that is xi yi. Okay, so when we do the xi square, that is 0.1 square, that is 0.01. 0.2 square is 0.04. 0.3 square is 0.09. 0.4 square is 0.16. This is 0.25, and this is 0.36. Now we'll take the square of y's. The square of y is 5.1 square, that is 26.01. 5.3 square is 28.09. Okay, 5.6 square is 31.36. 5.7 square is 32.49. 5.9 square is 34.81, and 6.1 square is 37.21. Okay, then we'll take the xy, that is we have to multiply x with y. That's 5.1 into 0.1, that is 0.51. 5.3 into 0.2 is 1.06. Okay, then the next value, that is 0.3 into 5.6 is 1.68. 0.4 into 5.7 is 2.5. 0.4 into 5.7 is 2.28. It's 2.28. Then it is 0.5 into 5.9, that's 2.95. 2.95. And we have the last one, 0.6 into 6.1, that is 3.66. Okay, so this is 3.66. Now after doing this, what we'll be doing, we have to take the summation. Okay, so first of all, we'll be taking the summation of xi terms, that is summation of xi. This will be summation of yi terms. This will be summation of xi square. summation of yi square, and this will be summation of xi yi. We have to sum these terms. Okay, so 0.1 plus 0.2 plus 0.3 plus 0.4 plus 0.5 plus 0.6, that's equal to 2.1. Okay, similarly the summation of yi terms, we have to perform the summation of yi terms, that will be equal 5.1 plus 5.3 plus up to 6.1, that is 33.7. So we'll write here this is 33.7. Okay, similarly we will have to take summation of xi square terms, that is 0.01 to 0.36, that's 0.91. Okay, similarly summation of yi square terms, that's equal, sorry, the summation of yi square terms, that's equal 189.97, 189.97. Then summation of xi yi, that will be equal 12.14. Okay, this is quite easy procedure. Fine. Then we will have to use certain formulas for finding the values of this a2 and a1. Okay, as far as the value of a2 is concerned, a2 is written as a2 is equal to n times summation of xy, summation of xi yi minus summation x into summation y divided by n times summation x square minus summation of x whole square. What does this mean? N means number of terms we have. We have 1, 2, 3, 4, 5, 6. So for us, n is equal 6. We'll write here 6. Then we have summation xy. Summation xy is 12.14. So we'll write 12.14 minus summation x, that's 2.1 multiplied by summation y. Summation y is 33.7. So we'll write here 33.7. Okay, divided by n times, that is 6 times summation of x square, that is 0.91 minus summation of x whole square, that is 2.1 whole square. Okay, so as we solve this, this comes out equal 1.97. Okay, this is the value of a2. Okay, now the formula for a1 is, we'll calculate the value of a1. The value of a1 is calculated as a1 is equal summation of y multiplied by summation of x square minus summation x into summation xy whole divided by n times summation of x square minus summation of x whole square. That's equal, when we take summation of y terms, that is 33.7. Okay, so we have 33.7 minus, multiplied by summation of x square terms, that is 0.91 minus summation of x, that's 2.1 into summation of xy terms, that's 12.14 whole divided by, that is n is 6, summation of x square is 0.91 minus summation of x square is, that is 2.1 square. Once we solve this, the value of a1 becomes equal to 4.93. Okay, therefore this data that is given to us in terms of x and y, that is this data, can be represented in the form of a straight line, that is y is equal to a2. A2 is 1.97. That is 1.97x plus a1, and a1 is 4.93. This is the equation of the line. Now we will check it. Now in this, let's take a random value 0.3. Substitute the value of x is equal to 0.3. Okay, so let's do this random testing and see whether our straight line is correct or not. So as we do it, for x is equal to 0.3, what is the value of y obtained from this equation? That becomes 1.97 multiplied by 0.3 plus 4.93, and that's equal 1.97 multiplied by 0.3 plus 4.93 is equal, that's equal to 5.5, 5.57, which is approximately equal to 5.6. Okay, that is the value which is given over here. Fine. So this is how we calculate, this is how this data has been represented on a straight line. This is called fitting the curve on a straight line. These two formulas are important for finding a2 and a1. Then using y is equal a2x plus a1. Okay, this is quite easy. Now let's talk about fitting on a nonlinear curve, and let's talk about an exponential curve. Okay, for example, we have an exponential curve. The exponential curve or of the formula y is equal to a e raised power b of x. Okay, so if we have the data, I will say fitting a nonlinear curve, and the nonlinear curve we have is an exponential curve. An exponential curve is of the form y is equal a e raised power bx. Okay, where a and b are constants. Okay, so let's suppose we are given some data. We are given the values of x I, we are given as 1, 2, 3, 4, 5. We are given the values of y as 2, 3, 1, 5, 6. Okay, now we want that this data should be represented in the form of an exponential curve of this form. Okay, we have to find the value of a and b first. Okay, so for finding the value of a and b, the formula for b is, the formula for calculating b is given as b is equal n times summation of x log y minus summation of x into summation of log y whole divided by n summation of x square minus summation of x square. This is one thing. And we also find the value of another constant that's called c. C is equal summation of log y into summation of x square, okay, minus summation of x into summation of x log y whole divided by n times summation of x square minus summation of x square. And from the C we obtain B because we say A is equal e raised power c. So once we know the value of c from this equation, we get the value of a. Let's try. So with these formulas in hand, the number of terms that we have are 5. Okay, in order to make the problem quite a bit easy for us, let me take it in terms of, okay, that's fine. So this is x, this is y. So I will first of all take the values of log y. Okay, so here we will be taking the values of log of y, log y. So log of 2 I will be first taking up. So when I go to take the log 2, that's equal to 0.30. So that is 0.30. Then I have log of 3. Log of 3 is 0.477. That's 0.477. Then I have log of 1, that's equal to 0. Then log of 5, that is 0.69. Then I have log of 6, that's equal to 0.77. Fine. Then I will multiply x with log. So I will take one more xi log of yi, another entry. So 0.30 multiplied by 1 is 0.30. 2 multiplied by 0.47, that is 0.94. This is 0. 0.69 into 4, that is 2.76. Then 0.77 into 5, that is 3.85. Okay, so this is 3.85. Fine. Yes, then I will also take x square terms. I will take x square terms. Let me I know y square. Okay. Okay. Xi square, that will be 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. Okay, fine. Now how many terms I have? We are having the number of terms that we have. We have 1, 2, 3, 4 and 5. So for us n is equal 5. We're having 5 number of terms. Okay, so let's find the value of b first. I know this is equal to b and this is equal c. Okay, so first when we find the value of b, the value of b will be equal to n times, that is 5 times. Okay, first I have to do summation here. Let me do this summation. So summation of xi will be 2 plus 1 is 3, 3 plus 3 is 6, this is 15. Summation of log yi terms, I do need that. Summation of log y terms, that is 0.3 plus 0.47. I will write it here. Sorry, this is summation of log yi that is 2.23. 2.23. I need x log yi summation. I will take its summation as well. That's equal 0.30 plus 0.94 plus 2.76 plus 3.85. that is 7.85. Then summation of x square will also be taken up. Okay, that is 55. Okay, this is summation of all these terms, that is summation of xi square. Fine. Fine. This will be 65, sorry. Okay, so now let's go and solve this. Quite easy. Now we have to substitute in this equation. So as we find the value of let me take the value of a first. The value of a will be, as per the graph, as per the formula, the value of a will be equal, let me clean this much, a will be equal, a becomes equal n times, n is 5, then I have summation of x log y, then x log y summation is 7.85, this is 7.85 minus summation of x is 15 into summation of log y terms, that is 2.23, whole divided by 5 times summation of x square terms, that is 65, minus summation of x and then whole square, that is 15 square. Okay, that comes out equal to, that is 7.85 multiplied by 5 minus times 15 multiplied by 2.23, that is 5.8. Then I have to divide it by, so that is 5.8 divided by 65 into 5 minus 225, that is 100, that is 0.0058. Okay, now yes, this is the value of a. So we'll reserve it somewhere and we'll say the value of a, sorry, not the value of a, b, the value of b is, value of b becomes equal 0.0058. This is the value of b. Now let's talk about the value of c. Now as far as the value of c is concerned, the value of c is equal, this is a summation of log y, that is 2.23, multiplied by summation of x square terms, that is 65, minus summation of x, that is 15, into summation of x log y items, that is 7.85, divided by 5 times summation of x square terms, that is 65 minus 15 square. Okay, so this becomes equal 2.23 multiplied by 65 minus 15 times 7.85, that is 0.272. Value of c is equal 0.272. Okay, now we'll substitute the value of c here to obtain the value of a. A is equal e raised to power c, that is 0.272. Okay, so so the value of a becomes equal, will be equal 1.31. Okay, therefore as we substitute the value in our equation of the nonlinear curve, it is y is equal y is equal to a, that is 1.31 into E 0.0058 can be written as 0.006 x. This is the exponential curve in which our given data fits. Okay, so our exponential, this is the exponential representation of our data. This is the exponential representation of our data. So we have represented the given data exponentially in form of an equation. So even if we give the value of x here, we give the value of x, say for example 4. Okay, so our y will be equal 1.31 e raised power 0.024 at x is equal to 4. Okay, so the value we have to find now, it should be, for x is equal to 4, it should be exactly 5. Okay, so 0.006, as we are doing, we are multiplying it by 4, 0.024, yeah. So it is e raised power 0.024, that is 1.0 into 1.31. Okay, so by this way we can get the values of our given y. So this is how the function works. This is how we get the exponential graphs.